Hello everyone, welcome to Maths with Mr. J, and today I'm going to show you how to solve this exponential equation, which reads 15 raised to the power of y minus 3 equal to 3 raised to the power of y minus 3. We have to find y. I'm making this video in response to one of the comments I received in previous video I made. I solved similar question like this using two approaches, but the person said, why not introduce logarithm, which is a very good thought. I think the person's name is Mahi Sahish Kumar. Maybe I didn't pronounce it well. So I'm doing this video in response to your comment. So what we do here, I have to introduce log this time. First, we say solution. 15 raised to the power of y minus 3 equal to 3 raised to the power of y minus 3. Here we have to introduce logarithm. If we introduce log, we have log of 15 raised to the power of y minus 3 equal to log of 3 raised to the power of y minus 3. In law of logarithm, whenever we have log of p raised to the power of n is the same thing as n log of p. What you do, you bring down the power, we multiply the log. If we apply that here, y minus 3, we multiply log of 15 equal to y minus 3 times log of 3. At this point, we collect the like terms, or we move the log to one side. Then if we move log to left hand side, we have y minus 3 log of 15 minus y minus 3 log of 3 equal to 0. Next step, we have to factorize. Factorize means what is common. We discover that y minus 3 is common, then we bring it out. It becomes y minus 3 into log of 15 minus log of 3. In law of logarithm, whenever we have expression like this, we can write it as log of a minus log of b can be expressed as log of a all over b. If we apply that, we have y minus 3 log 15 all over 3 equal to 0. This is the same thing as y minus 3 log of 5. 3 divided by 15 will give you 5 equal to 0. Now the next step, we divide both sides by the coefficient of the bracket y minus 3, and the coefficient of the bracket is log 5. Then when we do that, we have y minus 3 log 5 all over log 5 equals to 0 all over log 5. Log 5, we cancel log 5, left with y minus 3 equal to 0 divided by log 5 will give us 0. Now to get y is equal to, when we move minus 3 to the other side of equal to sign, it will change to plus 3. Plus 3 plus 0 gives us 3. So y is equal to 3. This is when you apply law of logarithm to solve this type of problem, you will get 3. Now we want to use different approach to solve this problem and see if we get the same answer. If we have 15 raised to the power of y minus 3 equal to 3 raised to the power of y minus 3. By using different approach, we say solution. If we have 15 raised to the power of y minus 3 equal to 3 raised to the power of y minus 3. What we do here, we take 3 raised to the power of y minus 3 to the left side of the equal to. It will become 15 raised to the power of y minus 3 divide by 3 raised to the power of y minus 3 is equal to 1. Because when you cross multiply, you will still get back the same equation. Then if we have this, the powers are equal. If the powers are equal, we are allowed to do 15 over 3 all raised to the power of y minus 3. This power is affecting both the numerator and the denominator, is equal to 1. Then we can divide the bracket 3 into 15. That will give us 5 raised to the power of y minus 3 equal to 1. At this point, we have another law of indices that states that whenever we have a raised to the power of 0 is equal to 1. Now, what we do, we have to express this one in base 5. That is 5 raised to the power of y minus 3 equal to 5 raised to the power of 0, because 5 raised to the power of 0 will give you 1. Then we compare both sides. If we compare both sides, the base, we cancel base, left with y minus 3 equals to 0. Now we collect like terms, meaning y crossing sign of equality becomes 0 plus 3. Then y is equal to 3. Now we have another approach to this question. We have 15 raised to the power of y minus 3 is equal to 3 raised to the power of y minus 3. In this case, we have to introduce another law of indices. The law states that whenever you have a raised to the power of m minus n can be expressed as a raised to the power of m all over a raised to the power of n. If this holds, meaning the above expression will be written as 15 raised to the power of y all over 15 raised to the power of 3 equal to 3 raised to the power of y all over 3 raised to the power of 3. We can rewrite this expression by moving y to one side, then by keeping numbers to one side. And when we do that, we can move this 3 y to become the denominator and move 15 raised to the power of 3 as the numerator. And when we do that, we are having 15 raised to the power of y all over 3y equal to 15 raised to the power of 3 all over 3 raised to the power of 3. In law of indices, we can express this to be 15 all over 3 raised to the power of y equals to 15 all over 3 all raised to the power of 3. Then when we compare both sides, the bracket, we cancel brackets, left with y equals to 3 as the answer. Now we want to check if our answer is correct. What we do, we write the original equation, which is 15 raised to the power of y minus 3 equals to 3 raised to the power of y minus 3. We put y equals to 3. Then wherever we see y, we put 3. We have 15 raised to the power of 3 minus 3 equals to 3 raised to the power of 3 minus 3. 15 raised to the power of 3 minus 3 is 0 equals to 3 raised to the power of 3 minus 3 gives us 0. And in law of indices, we have x raised to the power of 0 is equals to 1, meaning anything raised to the power of 0 is 1. Therefore, 15 raised to the power of 0 is 1 equal to 3 raised to the power of 0 is 1. The left-hand side is equals to the right-hand side, meaning our answer is correct. If this helped, please subscribe, like, and share. Thank you very much. In the comment section, drop the type of method or approach you prefer. Thank you.